Welcome to today's American Security Project webinar. This is an on-the-record conversation that will be available for attribution. A recording of this conversation will be posted on our website. All audience members will be muted during the discussion, but please use the Q&A box at the bottom of your screen to ask any questions to the panelists. With that, I will turn it over to ASP CEO, Patrick Costello.
Great, thank you, Matthew. Good afternoon from Washington, everyone. I'm Patrick Costello. Welcome to today's virtual meeting and happy Earth Day. I'm delighted to be joined by my friend and former colleague, Dr. Varun Sivaram. Varun is the Chief Technologist for Special Presidential Envoy for Climate and American Security Project founder, Secretary John Kerry. Varun's a physicist, best-selling author, and clean energy technology expert with expertise spanning the corporate, public, and academic sectors. His 2018 book, Taming the Sun, Innovations to Harness Solar Energy and Power the Planet, received widespread praise and was called an enlightening and candid book that describes both the enormous progress that has already been made in exploring solar energy and the major obstacles to further progress. As I mentioned before, Varun is now a key advisor to Secretary Kerry, serving as the Senior Director for Clean Energy and Innovation. Since it's Earth Day, I'd be remiss if I also didn't flag something from Varun's other boss. Secretary Blinken has shared a playlist on Spotify of songs that inspire climate action. So this Friday afternoon, I encourage you all to check that out. Varun, thank you so much for joining us. It's great to see you. Let's go ahead and get started. I understand that I'd like to start recognizing the context in which we're in with the war in Ukraine. And I know that you were just chatting with the secretary. I'd like to start with that. And I know that the Biden administration has come to embrace some US oil and gas in a bid to alleviate the supply squeeze that Western nations, as they shun Russian energy exports. And the secretary has said that there might be a momentary hold on the climate progress that we're making. But I do think that in this period, it might serve to accelerate some of the trends that we're seeing in decarbonization and green technology. I just welcome your views on that to start us off.
Sure, absolutely. Well, thanks, Patrick, and thanks to the American Security Project for having me, and happy Earth Day. Really glad that we can have the conversation today. Happy to jump right in on European energy security. As you know, in March, the United States and the European Commission had a joint statement committed to working together to reduce Europe's dependency on Russian energy. Europe, as you know, has a plan to repower EU to end dependence on Russian hydrocarbons well before the end of the decade, to end dependence on those imports. And the United States stands with our European allies to help them to reach that target. You asked a particular question, which is, will there be a pause in climate progress? And it's, as Secretary Kerry has made clear, not only can there not be a pause on climate progress, but it's very important that we understand that the near-term actions that we take here to shore up European energy security are entirely consistent with the long-term progress we need to make on the clean energy transition. Look, by the end of this decade, there's no getting around the facts. We will need to substantially reduce global emissions. We'll need to ramp up clean energy deployment, wind and solar power, for example, by 3 or 4 times. And we'll also need to invest heavily in innovation in the next generation of technologies. What we do in the very near term to ensure that the heat and the light doesn't go out in Europe doesn't need to jeopardize these 2030 and 2050 goals to get the world to net zero by around 2050 and keep alive the hope that we can limit global warming to 1.5 degrees Celsius. And actually, the right way to look at the European energy security situation right now is as honestly very aligned with the imperative of moving to a clean energy transition. Because at the end of the day, the only true way to guarantee European energy security and end dependence on imports is to move to clean energy sources rather than imports of other fossil fuels in the long run. So let me pause there, Patrick, but a great place to start because that is the backdrop where we find ourselves today, and there is no excuse for pausing climate action now.
Great. also like to, obviously the pandemic has created some enormous challenges for businesses, not to mention for individuals. But I think that COVID-19 has also produced a unique opportunity to rethink our ways of working. It's also demonstrated that collective action is possible, that science matters and should be taken seriously, and that governments can and should act rapidly to lead. And we've also seen a huge increase in pressure around climate change in the last couple of years. And with the post-COVID imperative to build back better or have a green economy, I think there are likely to be a number of companies seeing this as a necessity. So I guess the big question to you is, how do you see the impacts of the COVID-19 crisis on the net zero transition and a lot of these trends that we're seeing take place?
A range of interesting things that we learned. For example, in the first year of the COVID-19 crisis, we saw energy demand and emissions fall. And they fell at about the annual rate that you're going to need over the next 30 years to actually get to net zero. But obviously, all of us recognize that that's not a sustainable way to reduce global emissions. And very starkly made the point that we don't want to sacrifice economic development to meet the imperative of climate change, that there has to be instead a series of investments, a growth pathway that's consistent with economic benefits and a clean energy transition. Second, I think in the immediate term that there was a large stimulus effect that supported, for example, it started to support green infrastructure. One of the surprising things that came out of the pandemic, Patrick, was that throughout that pandemic, solar energy, for example, rode through fairly straightforwardly, whereas coal dropped precipitously. Solar energy continued to produce around the world at the same level or even higher levels. You take a market like India, where solar and wind actually outperformed coal substantially throughout the pandemic. That, by the way, would not have been predicted by anybody before the pandemic hit. Going forward, I think countries have now recognized that these clean energy sources are mainstays of the new global energy system. And going forward, it's now our task to just accelerate it. However, I will note that the world faces challenges. We're in a supply chain crunch across many sectors, and renewable energy has not been spared. Across the solar supply chain, across the wind supply chain, component prices went through some volatility. And so after years of fairly consistent pricing declines in solar and wind, for example, and batteries, we have had some turbulence in these clean energy commodity markets. So that's something that as these markets mature, every market goes through periods of volatility. In the clean energy case, we have to develop the tools to buffer the volatility and to continue to deploy at the pace we need to, even if prices aren't consistently going down at the same rate.
Great, thanks, Varun. And let's continue to discuss solar a bit, and let's turn to your book, which, as I mentioned, received widespread praise and was called the best available overview of solar by the Financial Times when it came out. It's certainly worthwhile praise from them. You do a deep dive into solar energy, the world's cheapest and fastest growing power source, but you also warn that its rise is in danger of stalling. You've just addressed some of the accelerating trends we've seen in solar during our pandemic period. And when you wrote your book 5 years ago, so if you warned that a red hot solar market could cool down, do you still have that fear, or do you think that we're beyond that and we're just going to see an accelerating? Provided the materials are available, given our supply chain crunch, we'll see an accelerating adoption of solar.
Great question, Patrick. I think we worked together when I wrote that book, and so you and I had many conversations about it. Look, I still have these same fears. At the same time, so I published the book in 2018. Since then, the price of solar has actually fallen faster than I anticipated, and I had said in the book that it would continue to fall fairly fast. So solar has done great, but the challenge ahead of us is daunting. Between now and 2030, every single day, the International Energy Agency forecasts that the world has to build the equivalent of the world's largest solar farm every single day between now and the end of the decade. We're nowhere close to deploying solar at that rate. And solar is, and I did say this in the book and I stand by it, solar is the single largest tool we have in the toolkit to fight climate change. The single largest tool in terms of the aggregate emission reductions we can hope to get from any one technology. Solar, more than any other technology, will underpin the global economy if we get to net zero, or when we get to net zero. So it's the most important thing to focus on. I'm very glad we have a chance to talk about it. There are a few key challenges that face solar. I just mentioned the supply chain challenge, and that has kind of two components. The one component is volatility in the market. So if you have a supply crunch, it takes a couple of years to sort itself out. So polysilicon prices, for example, spiked about a year ago, and they're coming back down again. And that's normal market volatility. The more worrying thing for me is this trend I'm seeing toward protectionism. Around the world, there are countries very legitimately wanting to invest in energy security, but impeding the free flow of clean energy. And as a result, the price of clean energy ends up going up. It's harder to deploy the clean energy when there are trade restrictions. So that's clearly a headwind for solar going forward. Another headwind is, and I wrote about this in the book, is whether the next generation of solar technology can take off. There have been exciting advances in laboratories, but it's still the case that the pace of solar technology development has been sluggish. Down the road, the headwind that I wrote about that most worries me is we get to a point in grids around the world where solar has been deployed up to a ceiling, where the investments haven't been made in the grid flexibility, in the storage, in the transmission, in the other power plants that will buffer intermittent wind and solar, or in the cheap solar technology itself. And if you get to that point and you haven't made the decades-long investments needed to achieve a truly flexible electricity system that can connect solar not only to power uses like in buildings, but also to new uses in industry and transportation like electric vehicles. If you haven't made those investments in time, then the solar surge could stall. That's what I wrote. Now, in my new perch in the Biden administration, I am delighted to see both our government and governments around the world taking proactive steps to invest in a range of these items. For example, the Biden administration, along with Congress, passed a bipartisan infrastructure law. We'll invest in grid modernization, for example. We have a Earthshot, a research and development push to drive down the cost of long duration storage to make it possible to buffer this intermittent solar energy. Our Department of Energy published a study showing that the US solar potential is just enormous if we can realize it. So that's why we're actively working to make sure that the solar surge does not peter out.
Just to continue unpacking solar a bit, I know before we were colleagues, you were running a lab at Oxford while you were doing your PhD. Can you talk a bit about some of those exciting developments that are happening in laboratories? What really gets you excited, whether it's advances in material sciences or anything else?
Yeah, well, look, Secretary Kerry, who I work for, recently made a trip out to Silicon Valley. And when we visited Stanford, for example, we visited with companies that are developing the next generation of solar technology. And so today, most solar panels are made of a material called silicon. And those panels continue to get more and more efficient as the industry incrementally improves them. But the breakthrough technologies, these are technologies that are supported by the US National Laboratory and REL. They're supported by universities. These technologies, for example, perovskite solar PV, these technologies could be far more material efficient. They, by the way, would probably use only materials from countries that the United States has no energy security concerns with, or can source them domestically. They can be far more efficient. So existing silicon solar panels, the theoretical efficiency limit is somewhere in the vicinity of 26, 27%, but these hybrid materials can actually break the 30% efficiency threshold. That means that you can have more power out of the same area of land and a lower cost to install a given power output of a solar installation. And then these materials can be extraordinarily flexible and versatile. You can imagine they could be printed out of an inkjet printer. They could be flexible. They could be colorful, semi-transparent. You can put them on buildings. So there's a whole new set of capabilities that you'll develop. You can put them on electric vehicles or drones. We can develop these once we take that next step toward commercializing technologies that are still in the laboratory. And I think this is a critical decade for commercializing the solar technology, so that in the 2030s and 2040s, we massively scale up solar that is an order of magnitude cheaper than the cheap solar that we already have.
Final question on solar, because there's a lot of other issues that I want to get to, but I know that this is something that you're quite passionate about. Now, in your book, you offer a set of policy recommendations to reshape solar into a global technology-driven industry that would make use of and enhance the U.S. strengths. I want you to unpack some of those policy recommendations. You talked a bit about trade restrictions and trade policy. You briefly mentioned the grid modernization efforts that were in the bipartisan infrastructure law. What other recommendations would you have directly for policymakers?
I now sit in a different perch, so let me not make recommendations to ourselves, but instead, Patrick, let me say this is a historic opportunity for the United States to become globally competitive in a range of burgeoning clean energy technology industries. Look, I'll be blunt. In some existing technology industries, in existing solar panels, for example, the United States has not competed very well. China, for example, dominates the production of solar panels in the supply chain. But going forward, there will be these multi-trillion-dollar markets in next-generation solar, but also in hydrogen, in long-duration energy storage, in clean steel, in direct air capture and carbon dioxide removal, in industrial decarbonization, clean fuels. I could go on and on. Digital smart grids, where the United States actually could stake out a global leadership position. It's more than just deploying these technologies at home. We are ourselves a large market, but the global market's the real big prize. Multi-trillion-dollar markets will emerge as the clean energy transition picks up pace. And the United States now has an opportunity to position itself across these dozens of technology areas to win significant market share, particularly in the emerging markets that are growing fast around the world. And to do that, the Biden administration is investing in a range of tools. We have our existing authorities through, for example, the Export-Import Bank. We have the ability through our TDA to go around the world and identify interesting commercial opportunities. Our Commerce Department supports our firms. And we've also launched a coherent American clean tech competitiveness strategy process, where we are inventorying all of these different opportunities across technologies, including solar, and then developing a coherent set of tools that we can take, for example, through our Build Back Better World initiative to make sure that around the world, as infrastructure is built in a way that advances our standards, it's American technologies and American companies that are seizing market share. This climate crisis is also an unprecedented economic opportunity. As my boss, Secretary Kerry, has often said, it's about time the US starts to seize it.
Certainly is economic opportunity there. I want to pivot slightly and talk about nuclear. Secretary Moniz was quoted in Politico today as saying that that nuclear, it could be the holy grail that could propel the country towards zero emission energy. Just want your thoughts on nuclear's potential, but also there are some challenges in the regulatory space as well as in terms of public perceptions. So if you could speak briefly to those as well.
Well, look, we are big supporters of the next generation of nuclear reactors. Advanced nuclear, whether small modular reactors or other generation 4 nuclear designs, have the potential to be modular, lower in cost, higher in efficiency, have more beneficial fuel cycle and safety attributes. Particularly safety, inherent safety is a selling point of many of these upcoming designs. As you know, the Department of Energy, through much of the funding through the bipartisan infrastructure law that President Biden signed, has the ability to now invest billions of dollars in demonstration projects of this new wave of nuclear reactors. And advanced nuclear is one of those technology areas where the US can be globally competitive. We've already worked with partners around the world, such as Romania, to work on priming the market for American exports of American technology and helping them to meet their climate goals in a way that is, nuclear can provide flexible, often baseload electricity that can complement the electricity coming from solar and wind that are also intermittent sources. So look, all I'll say here is there is full-throated support for nuclear as a tool to advance the fight against the climate crisis. And it's going to take American innovation and American competitiveness to really bring this technology to its full potential.
Great, thanks. I want to talk a bit about digital innovation. How can digital innovation in the energy sector speed decarbonization? What's the potential for digital technologies to speed clean energy transition? And also, is there a downside? Could digital innovations make it easier to extract fossil fuels and thereby not actually advance the green energy transition in the ways in which we want?
Yeah, I mean, look, digitalization, this remarkable trend, is sort of an equal opportunity helper. It could help a fossil fuel company more efficiently extract oil or, reduce the cost of fossil fuels. It could also help a solar company more efficiently clean its solar panels, or a wind company more effectively, predictably maintain its fleet or produce more energy. I think, therefore, that the way we harness digitalization is what is going to determine whether that is a trend that advances or impedes decarbonization. And I think, and you and I have talked at length about this, Patrick, I think digitalization may be one of the most powerful tools we have. It's powerful for a few reasons. First, it's not that expensive compared with all the other things you can do in the energy sector, which is invest lots of money in high capital, heavy infrastructure projects. Digitalization is often a fairly cheap thing to do. Second, the pace of increases both in the computing resources we have available, as well as the algorithmic things we've done on machine learning and AI, mean that digitalization is now an extraordinarily powerful tool. We can make a lot more sense of the data that we have, for example, in orchestrating an electricity grid at the distribution level than we ever could before we had these resources. And third, I think there's a wave of companies, both at the startup level and at the mature level, that's raising a wave of capital on digitalization. And so the money and resources are there. It's time for us to figure out what to do with it. And it's important to distinguish between what are really the high value things you can do with digitalization and what are some of the marginal things you can do. I think, for example, the more efficient operation of electricity markets to best value new emerging clean energy assets, such as storage, that is a real high value use of digitalization and the use of data. Similarly, I think the use of digitalization to effectively digitalize clean energy assets, to make our wind farms and solar farms, particularly offshore wind farms, digital virtual assets, means that we can maintain them and ensure that they're producing the most energy that they can without really expensive maintenance operations. For example, sending out a boat every time something appears to be wrong with an offshore wind turbine. Robotics, in addition, are providing us a new avenue to enhance the clean energy space. When I was in India, and I previously served as the chief technology officer of India's largest renewable company, I focused heavily on bringing robotics to help to clean our solar panels and also to use the sensor readings from the robots in order to monitor our assets. So I'm very excited about the potential for digitalization to advance decarbonization, but we have to be intentional about it because it could cut both ways.
Thanks, Varun. I want to let's turn to what the so-called hard to abate sectors. We all know that companies across the board are working hard to get to net zero emissions by 2050. Strategies including using renewable energy to power their buildings, transitioning to EVs for transportation delivery systems, offsetting carbon footprints by investing in green causes like reforestation. But for heavy industries and heavy duty transportation companies, reducing their emissions can be much harder. So a couple of questions here for you. One, for those not tracking this closely, what are these hard to abate sectors? Second, reporting in the literature I've seen is that many countries' national strategies to meet the Paris Agreement on emissions reduction do not address hard to abate sectors. Are you seeing a shift there? And then third, what are some of the strategies being employed in these particular hard to abate sectors?
Great questions, Patrick. Let me just start with the first one, which is whereas the energy transition has really started in the power sector, we're seeing massive deployment of wind and solar. We're seeing electric vehicles starting to be deployed. $750 billion in 2021 was invested in the clean energy transition. Almost none of that is going toward these hard to abate sectors and the decarbonization efforts there. When we talk about hard to abate, we're talking about roughly a third of global emissions, which could grow to half of global emissions on the current course and speed. And they're across heavy industry and long distance transportation. These are the places where today's clean energy technologies aren't already very competitive with the fossil fuels. They include, on the heavy industry side, steel, aluminum, chemicals, fertilizer, and on the long distance transportation side, shipping, trucking, aviation. The United States, through Secretary Kerry and President Biden, has launched a flagship initiative on decarbonizing hard to abate sectors called the First Movers Coalition. And this is a consortium of private companies, all of whom have made very ambitious pledges toward creating an early market for these emerging technologies that will need to decarbonize the hard to abates. It's sort of like the model for bringing vaccines onto the market or commercial space flight by sending an early market signal that, hey, this market exists and there's a commitment to buy the technology. The innovators and financiers have an incentive to develop those technologies and bring them to market. And so just as we did for vaccines and for the first private commercial space flight from SpaceX, we are now working with companies to create those early markets for clean steel, for clean shipping, trucking, aviation, and at Davos in just a few weeks, because we're doing this in conjunction with the World Economic Forum, the First Movers Coalition will announce 2 new sectors in carbon dioxide removal, in aluminum, and will announce a range of new companies who are joining the consortium. So it's an exciting time because these are the companies that are really doing something unprecedented. They've stepped forward and are pledging to buy these technologies that haven't yet made it on the market. It's maybe the highest leverage action that any corporation can take. Look, I know we've only got a couple minutes, Patrick, and today's Earth Day, so you're going to hear a lot of noise. On any climate-related day, there's a ton of noise. Everybody will say they're doing something. Very few are actually doing things that are truly meaningful. And companies that sign up to the First Movers Coalition are making a truly meaningful commitment by creating an early market that can help a technology scale that could literally change the world. It's more impactful than a company reducing their own emissions or a company buying offsets, as you mentioned, Patrick. The most effective, high leverage thing a company can do is to invest in the innovation, either the supply or in this case, the demand for that innovation, so that technology costs fall and they become more accessible, particularly in these hard to abate sectors.
Thanks, Varun. I know we're nearly out of time, but with my final question, I want to bring this back home for you. And I know that you previously worked for Ambassador Eric Garcetti when he was the mayor of Los Angeles. So I'd like your thoughts on what you see as the role of cities versus national governments in making changes necessary to curb emissions.
Look, I think at all levels of government, there is an important role to play in the clean energy transition and in fighting climate change. Cities have demonstrated remarkable leadership. At the end of the day, many cities are able to pass impactful policies, particularly in the power sector, across transportation. Cities that pass congestion charging policies, for example, can both reduce air pollution and they can reduce carbon emissions. And it's the cities in the emerging economies where we're seeing emissions growth that's particularly pronounced. In emerging economies like India, where urbanization is progressing rapidly, it's those fast-growing cities that now have the opportunity through things like building codes to limit energy use and advance energy efficiency, through congestion charging to limit the use of to limit emissions and air pollution from driving, and through intelligent design of transit and livability to ensure that those who live in those emerging cities have high quality of life while at the same time having a low carbon footprint. The cities are where I think a lot of the action is going to happen, even as at the national level, national policy frameworks can set the table through, for example, carbon pricing that we see in the European Union or Canada. these high-level federal initiatives kind of level the playing field between clean and dirty alternatives, but it's at the local level where initiatives like building codes, applying standards, and congestion charging can ensure that we really have livability alongside limited carbon emissions. So delighted that, Patrick, we're ending on the city point, because that's also a place where today on Earth Day, folks who want to take action often find it easier to take action at the local level, and there's a whole lot we can do there.
Well, Varun, we are out of time. I greatly appreciate you joining us for this timely and important conversation. Really great to see you, my friend. It's been too long, and keep up the great work.
It's really great to see you, Patrick. Take care. Look forward to catching up, and thanks to everyone who joined.
Thank you for joining, everyone.